Well, suppose we have an oriented surface given by a vector valued function, and the vector valued function is given as a parametric surface of two variables, r of uv equals x of uvi plus y of uvj plus z of uvk. Then we can define the flux integral as integral of f dot n ds over the surface S, which is f dot the length of, actually we'll say it like this, the derivative of r with respect to u cross the derivative of r with respect to v divided by its length times its length, so it's really just f dot this vector here dA, and so that's what we wind up with over the region D, the shadow of this in the UV plane. So here's an example. Find the flux over the portion of the sphere given S, by the way that's the surface, given by x squared plus y squared plus z squared equals 16, but that lies in the first octant where the force field is F equals xi plus yj plus zk. Assume the sphere is oriented with an outward, and the first thing we need to do is write the sphere parametrically. So that would be r of uv equals 4 sine of u times cosine of v plus 4 sine of u times sine of v. Oh, that was times I forgot. Plus 4 sine of u times sine of v times j plus 4 cosine of u times k. If you look into the formula for how to convert from spherical coordinates, or actually two spherical coordinates from rectangular, you should see how that all works out. But remembering that in spherical, x equals r cosine theta, and what we need to think about this is the sphere has radius 4, so 4 sine u is our r, and here's the cosine theta, like I said. So here's 4 sine u j, or sorry, r sine theta j, but r is 4 sine of u, and plus 4 cosine of u times k. So if you need a reminder, go back to see how you convert from spherical to, from rectangular to spherical coordinates. So anyway, that gives us the partial derivative with respect to u of r is, well, the derivative 4 cosine v would just be a constant, and the derivative of sine is cosine, so we get 4 cosine u cosine v. Here, partial with respect to u, then 4 sine v is a constant, so we get 4 sine v times the derivative of sine, which is negative cosine. Yeah, that should be negative 4. Pardon me. Cosine u sine v, and then derivative of cosine is negative sine. Whoops, wait a minute, I'm wrong. Derivative of sine is positive cosine, so not integrating. And derivative of cosine is negative sine, so there, I think we're good. RV, partial of this with respect to v, well then 4 sine of u is a constant, derivative of cosine is negative sine, so negative 4 sine u sine vi. Derivative of this with respect to v is cosine times this constant, so 4 sine of u cosine of v. Yes, that would do it. And then plus the derivative of this with respect to v, since this is just a constant, is 0, plus 0k. So our u cross rv, we need that for this part of the formula right here, is ijk across the top, 4 cosine u cosine v, that's from here, 4 cosine u sine v from here, and negative 4 sine of u from here. Right, there we go. R, with respect to v of uv, is 4 sine u sine v, with a negative sign in front of it right there, so that's here. And then 4 sine u cosine v here, and 0 for the k component there. So my, this is a complicated animal. So it's I times its minor, which is this times 0, minus a negative, so we'll call it plus 16 sine squared u cosine v. There we go, there's that part. Minus j times its minor, so 4, this times 0 disappears, and then minus a positive, and don't forget the negative in front of the j, so we're going to wind up with 16 times sine squared u sine of v. Okay, ultimately this comes around to be a positive, I guess, because of the double negatives there, but we'll worry about that when we simplify it. And then k times its minor, which is 16 sine of u cosine of u cosine of v squared, minus a negative, so we'll say plus 16 times cosine of u times sine of u times sine of v squared. There's that part, and that's all times k, of course. Now here comes the fun part where we simplify this mess. Well, not much to simplify here, unfortunately, and not much to simplify here other than minus the negatives to find a plus, but here we got something. Notice that cosine squared v plus sine squared v equals 1, and if you factored out the rest of it, it's 16 sine of u cosine of u. So there's that part times 1 times k. And so now our function f, recalling, was xi plus yi plus z, yj plus zk. And so our function f is x. Recall this is what I put in for x when I moved to polar from since that's what my x is here, so plus yj, well, there's the yj plus zk, so there's my vector field f written as a vector value function. So f dot ru cross rv is, well, here's our f, all this dot with, here's our ru cross rv here, and when you dot, you multiply the I components, so we got 4 sine of u cosine of v times, wow, 16 sine squared of u cosine of v, so 4 times 16 will give us 64. Sine here and sine squared means sine cubed. Cosine from here and cosine from here means cosine squared v. Plus, let's multiply the j components. We got 4 sine of u sine of v times 16 sine squared of u sine of v, and that would give us 64 times this sine squared, so sine cubed u, times this sine, so times sine squared of v, and then finally 4 cosine of u times 16 sine of u cosine of u, so that would be 64 cosine squared of u times sine of u. Okay, there's all that. Now let's see if that simplifies, and the answer is, well, of course, if we factor out 64 sine cubed, we got that times 1, so we got 64 sine cubed, and here we have 64 times sine times cosine squared. Well, again, if we factor out sine of u, we have sine of u times, actually 64 times the sine of u times sine squared from here, and cosine squared from here, so we got another 1. So our f dot u, ru cross rv turns out to be very simple, ultimately 64 times the sine of u. So our integral is 64 sine of u du dv. Y, you're asking, does u go from 0 to pi over 2 and v go from 0 to pi over 2? And the answer for that question is, don't forget that we were looking at the sphere lying in the first octant. And so our d would just be 0 to pi over 2 and then 0 to pi over 2. That would keep us in our first octant. So ultimately we come up with an answer of 32 pi. It's too easy to do that. Integrating sine of u du, we would get negative cosine of u evaluated between 0 and pi over 2, and that would be positive 64, and then integrating with respect to v, we would just get 64v, but v goes from 0 to pi over 2, so we would get 64 times 32, or 64 times pi over 2, which is 32 pi.